All right, systems of linear inequalities. Okay, our objective for today is going to be to write and graph systems of linear inequalities to model some problems. So first, what is a system of inequalities? Very similar to our system of equations with equalities, is it consists of two or more inequalities having the same variables. So instead of only having one inequality that we need to graph, we're going to be having two. So this is, again, really just extension of the last section, because for this section then, we just now have to graph both of them. Because when solving, you need to find a point that works in both systems. So this is where color coding works great. So if you don't have access to other colored pencils or colored markers or pens, you go ahead and I do have some colored pencils you can borrow. Color coding works great as far as like coloring one graph in blue and then the other one in red and then where they meet in purple. Okay. All right, so here we're going to graph the system of linear inequalities. So first I just need to graph them both. So this is just basically what we did in the last section. So here I'm going to graph this first one here in blue. So my boundary line is y equals x plus 4. So it's going to have that y-intercept of 4. So let's come over here and let's graph him. Okay. He's going to have a y-intercept of 4, which is right there. Oh, excuse me. Sorry. There, and a slope of 1, because there's 1x there. So 1 over 1. So he's going to go up 1 over 1, up 1 over 1, up 1 over 1. I'm going to grab my ruler to draw him. Like that. Okay. And then we need to figure out, first of all, it is strictly greater than. It is strictly greater than, not equal to. So this line needs to be dashed. So I need a dashed line. So I'm going to grab my eraser and we're going to come in and we're just going to erase chunks of it, make him dashed. Okay, so there's my dash line. And this is, I want all the y's that are greater than. So the y's that are greater than that line. Well, again, y goes up and down, so greater than would be above. So I want to go ahead and shade above. Blue. We're going to shade above there in blue. So there. All of those points that are shaded in blue will work. Always good to check a point. I don't know. Let's check this point. Negative 1, 2, 3, 4, 5. Negative 5, 1. The point negative 5, 1. We check it. So 1, is that greater than negative 5 plus 4? 1 is greater than negative 1. Yes, it worked. Okay, so we checked a point. Okay, so that's only half done. We only did the first equation. We now have to do this one as well. So 4x plus 3y is less than or equal to 12. I think I'm going to get that in slope-intercept form. I'm going to subtract 4x from both sides. So 3y. I'm going to put the negative 4x first because we like mx plus b. Divide both sides by 3. Now I have to divide both parts of these by 3. So that would be negative 4 divided by 3x plus 12 divided by 3, which is 4. So this one also has a y-intercept of 4, but this one has a slope of negative 4/3. There's the y-intercept. So this means I go down 4 over 3. So down 1, 2, 3, 4 over 1, 2, 3. Okay. Bring my ruler back in again. And let's graph this line. Again, I have my line. I take my line and I have it go all the way through my graph. Okay. Now this one is also equal to, so my line is going to be solid. So this one's going to be a solid line. Okay, and I want, come down here and look at this one. I want all the y's that are less than. So I want all the y's that are less than that. So less than that is if I put my pointer on the line, less than would be down. So we want to go down. So I'm going to grab, we highlight in red, we can. And we want to be less than. Okay. Okay, so everything below there. So the system, the points that will work in both of these are the points that are shaded both in red and in blue. So now I need to come in, and this is that final step. I'm going to come in and we'll shade with purple. I need to shade in the stuff that is for both of them to let the reader know exactly. So it'd be all of this stuff in between these two lines right in here. Okay. So all of this, any point here would be one that works in both. Okay, so if I pick a point out here, I don't know, negative 6, 0 out here, and check it in both, it will work. Okay, so let's try it in both. So let's try it in the blue one. So negative 6, 0. 0 is greater than negative 6 plus 4. Is 0 greater than negative 2? Yep. Okay, negative 6, 0. 4 times negative 6 plus 3 times 0. Is that less than or equal to 12? Negative 24 plus 0. Yep, worked in that one as too. Negative 24 is less than or equal to 12. So it worked there as well. So we're just looking for where both are shaded. Okay. All right, let's do another one here. We want to graph this following system. So again, we graph them both. We want to find the points that work in both. So again, we'll color code again. Let's do this first one in blue. Y is less than 2x minus 5. Y-intercept of negative 5. Down 1, 2, 3, 4, negative 5 right there. Slope of 2. So 2 over 1. Rise 2 over run, rise 2 over 1. Okay, let's grab that ruler. Draw in that line. Now, before I draw it, let's go ahead and look. It is strictly less than, so it's going to be dashed. So I can just draw it in dashed. Okay, so there's that line. Arrows on the end. Didn't do arrows on the last guy, but all right, next one. Oh, we got a shade. Which way do I shade? So here we're looking at ones that are less than. So if I'm on this line, I want to shade below. So it'd be everything down here. Okay. All right, so there's my less than that line. Next line. Okay, y is greater than 2x plus 2. Well, there's my y-intercept of 2. This one's also got a slope of 2 over 1. So my y-intercept of 2, 1, 2, up 2 over 1, up 2 over 1. So it looks like here these have the same slope, so that's going to make them parallel. This is strictly greater than, so dash line again. Okay. So now if we go ahead and shade this, which way would we shade? This one's greater than, so I need to, if I'm on the line, I need to shade above this way. Okay. Okay, and so now my final step is where are the points that are shaded both blue and red? There are none. This one has what we call no overlap, which means there is no solution. There is no point that will work in the blue equation because that's all the points down here. That will also work in the red one because those are the points up here. Okay. There's no point that will work in both. There's no way that I can multiply a number by 2 and subtract 5 and get a number less than, so it just doesn't work. There's no overlap. Okay. All right, now let's work backwards. Here, we're going to go ahead and we're going to have an equation here. And we need to write the equation. So we need to look at these two lines and write the equations for them. So over here, we kind of walk through that process. Oh, I don't need that right now. Walk through that process of finding the slope and the y-intercept and finding the slope and the y-intercept, and then determining which way it's shaded from that line. Okay, so first let's go ahead. I'm going to color code this a little. It's already kind of color coded, but let's go this top, let's go ahead and here for part A. So they're doing this line first. Here, I'm going to do green over top of it. This line right here. Okay, this one has a y-intercept of 4. And the slope goes up 1 over a half. No, up 1, 2 over 1 maybe. Down 2, 3, nope, 4. So it goes up 1. So it goes up 1, 2, 3, 4 over 1. Up 4 over 1. So the slope, up 4 over 1. So the equation would be y equals up 4 over 1, 4x plus 4. Okay, but I need to figure out what to do with this equal. Which way am I shaded in relationship to this line? So in this line, which way am I shading? Well, here it looks like maybe I'm shading this way until you get up here. I'm going to look where it's not shaded. It's not shaded in this little bit. And this little bit is on this side or below that line. So that means I'm actually shading this way above. So this would be a greater than. So I would get rid of this equal to, and it would be y is greater than 4x plus 4. Is the line solid? It is, so equal to. So there's my first equation. Y is greater than or equal to 4x plus 4. Okay, next one. So let's go ahead. Let's look at this guy right here. Okay. All right, this one's got a y-intercept of 1, 2, 3, 4. Up here, a y-intercept of 5. Now we need to determine slope. Up 1 over 1. It looks like it might be up 1 over 1. Yep, up 1 over 1. So slope on that guy is up 1 over 1, so 1. So my equation, y equals 1x plus 5. But again, we don't want the equal. That's just the line. We got to figure out which way I'm shaded. So this one I can tell it's not shaded above. If it was shaded above, it would be shaded up here. It's not shaded up here. It's shaded down here. So it's below. So that would be a less than. So this one would not be, it'd be a less than or equal to. So my system, y is greater than or equal to 4x plus 4. Y is less than or equal to x plus 5. There is my system. All right, one last problem, an application type problem. Here we have Jessica's going to a garden center to buy potted plants. Her favorites are pansies and mums. She wants to spend no more than $30. Okay, so she's spending money on pansies, plus the money that she spends on mums. Can't be more than, so it has to be less than or equal to $30. It can't be more than $30, but it could be equal to. She wants to spend no more than $30. So the amount of money she spends on pansies plus the amount of money on mums has to be less than 30. Okay, so that was for this little bit here. She wants to buy at least 8 potted plants. So here, basically, my number of pansies plus my number of mums, my number of total plants, I want that to be more than 8. Greater than or equal to 8. Pansies cost, over here, pansies cost $5. So that would be here under the cost section. The cost for pansies, it would be $5 per pansy, and mums, $2 per mum. So I would have, if I define my variable, if I let the number of pansies be x, if we want to stick this with x and y, and the number of mums to be y, again, define your variable, then that first equation becomes 5x plus 2y has to be less than or equal to 30. And the second equation, because x plus y has to be greater than or equal to 8. Okay. So there's my 2 equations. So we want to write a system. There, we wrote our system. There's our system equations right here. And create a graph to model all the combinations of pansies and mums that she can buy. Okay, first of all, this I really am only going to buy positive pansies and mums, so quadrant 1 is sufficient for this. So over here is my x, that's my pansies. And over here is my y, that's my number of mums. Okay, so let's go ahead, let's graph these two things. This one looks easier to graph, so I'm going to go with that one first. Y x plus y is greater than or equal to 8. I'm subtract the x from both sides. Negative x plus 8. Y-intercept of 8. Now, but do we want to count by ones or not? I'm not sure. Let's do the next equation to figure out what our scale should be. So we're going to do this next one. 5x plus 2y. I'm going to subtract 5x from both sides. So 2y is less than or equal to negative 5x plus 30. Divide both sides by 2. Y is less than or equal to negative 5 halves x plus 15. Okay, so here we have a y-intercept of 8, a y-intercept of 15. So I can probably count by ones, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15. Sure can. There's my y-intercept of 15. Down 5. 1, 2, 3, 4, 5 over 2. 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. Okay, grab my ruler. Draw it in. This is equal to, so that one could be solid. And we want to be less than that, so that would be all the numbers underneath. So let's go ahead and let's get my shading. We'll shade in red all the points underneath there. And we really only need to be the positive, so we're just looking at that little wedge. Okay. The next one here for blue. So y-intercept of 8. 1, 2, 3, 4, 5, 6, 7, 8. Down 1 over 1, down 1 over 1, down 1 over 1. So there's my line right there. And equal to, so we'll go ahead and draw that in. And I want to be greater than that line, so I need to shade above. So if I shade above that, but below the other, really, my spots at work will just be in that little bitty wedge. Okay, so any of the points in that little bitty wedge will work. Well, we can only do a solid number, so I could buy 1 and 8, 1 and 9, 1 and 10, 1 and 11, 2 and 7, 8, 3, and so I can come up with, here I could buy 3 and 1, 2, 3, 4, 5, 3 and 6, 3 pansies, 6 mums. Okay, or any other combinations. And it makes sense I can't buy nearly as many pansies. They're more expensive. They're $5. Unless I want, yeah, they're more expensive. I only have $30. So I can't buy nearly as many pansies. All right.